to be gaps. So there is a certain amount of assumption made here that the area between sampling intervals is the same. It probably is. Let's face it, we're not dealing with an unpredictable teenager, but we are dealing with a river which has got predictable forces of nature at work. Okay, that's not the only type of data presentation you've used. You have done scatter graphs, so could you tell me, because we were told by Miles there that bed load size showed a negative correlation. In other words, you're going to be looking at something like that, which is a very poorly drawn scatter graph. I'm sorry about that. But basically, as we saw the velocity increase, we saw the size of the bed load decrease. Now, first of all, why are scatter graphs a good way of showing data?
It shows correlation.
It shows correlation. It shows not just correlation, but the strength of it. Okay? Because if you can still have a negative correlation, but it might be like that. And so I know when I say like that for the podcast, that means nothing, but I'll take photos of these poorly drawn diagrams later. So you can see the strength of the correlation as well as the direction of it. That's what we like about scatter graphs. What else do we like about them?
You can compare two variables where usually it's just one variable.
Indeed. So you're not just looking at a change over distance, you're looking at a change against another variable. There are shortcomings though with scatter graphs, because we are the ones deciding on what we think are variables that might affect each other. It's not showing us everything at once. We're saying, I will look at velocity and pebble size. What if they haven't really affected each other? I've just chosen two variables. Maybe it's velocity and distance from the bank. Maybe I need to do that. All I'm saying is that a scatter graph, you need more than one to look at all the potential variables. Don't ever just draw one scatter graph and say, that's it, we've worked it out. It shows a correlation. That must be the only correlation or the only factor. It is simply one factor. You need to look at all the others as well, like distance from the bank, like bed load size, because bed load size might also affect the friction, therefore affect the speed of the river. It might be that you have got some people in your group who were standing just upstream from where you were doing your velocity readings, and they themselves have disrupted the factors and the readings. So remember, human error is also an issue here.
Could you also say that different people would have different ideas with which ones would be anomalies and which ones to cancel out? So it's kind of personal how you draw it.
It is. Everything is open to interpretation, absolutely. We do bring in significance levels to see if things are reliable or not. But even when you look at the very starting point of this, it's how people collected the data and might therefore cause anomalies. So maybe one group were very diligent and another group weren't. Okay, which is why we tend to look at averages a lot.
But I'm doing this on your own.
You are, but actually your write-up is personal, but you can never do river work by yourself. First of all, health and safety will say that you're not allowed to. And also the very nature of getting these readings means you cannot do it by yourself. It's understood by the examiner that you've probably collected them in a group, but your interpretation is entirely your own. Okay? So you don't have to pretend that you are Superman of geography and can do everything. Okay? So don't worry about that. Alright?
I think it's frozen, the recording.
Oh no.
That wasn't moving up and down.
It wasn't. You may not have heard that, but basically I just told Jamal he was wrong, which I think is worth recording twice. But basically, don't worry if the examiner reckons that you've done everything in a group, because they recognise that nobody can do geography fieldwork by themselves. Okay?
Data collection.
Sorry?
That's the data collection beginning of the group.
Yeah, the data collection is in a group, but the interpretation and write-up is your own. So other questions they've asked. Outline the findings of your personal research into river flooding. So you know the focus that year was flooding. And then the second bit, because the first bit's always there. So tell me first of all what you found, and then discuss the suitability of the methods of obtaining information you used. In other words, your method.
Is there a problem with the cumulative bar graph or not?
Oh yeah, I agree. Let's not completely go away from data presentation. Forgive me. So just to continue looking at data presentation, another way that you might present your data will be a cumulative bar graph. Now, what do we like and what do we not like about them?
I don't understand them.
You don't understand them, okay.
We tried Mr. John explain for hours and I still don't know.
Basically, it's a bar graph with between 100 and 0%, okay. We tend to use it with bed load shape. So I'll have perhaps 10 bars, or actually 11 bars, showing, if you like, the left-hand bank and the right-hand bank of the river. And I'll separate these bars into what bed load type they were. So I might have not that many of a very rounded nature. Remember, you maybe have on the top, might be useful of a way of presenting it, the actual shape of your channel. So you know this is your river cliff, and that's your slip-off slope. Okay? So you would expect, what would you expect to find near the river cliff in terms of bed load shape?
Be angular and
rounder, yeah.
Is
Where?
the cliff on the outside or the inside?
on the river
Outside.
cliff. River cliff will be small.
It's where all that
It cuts
massive
in
erosion is.
It can be small and rounded.
Small and rounded. So you would expect a
Outside, where it's flat.
very small number of the angular, but maybe more of the rounded.
Yes.
Okay? So that's all your rounded ones. So what would you expect around the slip-off slope in terms of shape?
Large and angular.
Ones and twos.
So less rounded but more angular.
Yeah.
So now I would expect maybe something like that. There's my angular, and maybe less smooth. Okay, so there's my smooth. And then something in between and everywhere else, yeah? So a cumulative bar graph will show you where the angular and rounded pebbles are found. Now you tell me what's useful about that. Is it easy to interpret?
Yes.
No.
Yeah.
Okay, it is easy to interpret. Does it give you any reasons for it? Does it suggest any variables that might have caused it?
But if you change that into an isoval thing above it, you could see like how they change with velocity.
So you're suggesting now ways of evaluating it, which is
Link
good.
them together.
So me doing this almost by accident now might be a valid valuation point. By saying if we were to map my depth and my velocity and my bed load size and shape all in one, you can basically say, well, I know why this is more rounded, because there's more velocity there. You see, so where we have lots of velocity, we're having more rounded but less angular, but where we have less velocity, we're having less rounded but more angular. So this could be a very nice way of presenting data, but by combining lots of factors into one graph. So you've got a cumulative bar graph as well as an isoval diagram. Just saying. And if you were to use the same axes for everything, it allows you really to make comparisons. So, how many groups did we have? 3, yeah? So you could have
4 smooth. Ragged.
So you might have each of the meanders. There's A, B and C, and at the same time alongside it you've got your depth readings and your bed load types by showing how much of that type we saw, whatever it might be. So that gives you a full map, if you like, of the area. Can I also suggest another way of presenting data? Is because on the day, you might remember, I climbed a tree and took a photograph of the area from above. Yeah.
I remember.
So I gave you a bird's eye view, which enabled us, alongside Google Earth, to do quite an accurate plan of the area. Okay? But photographs are another way of presenting data, because if I was to put my photograph on the page, then what could I do around it? I I could annotate it. So there's our Meander. Okay, there's Richard, who was having his lunch at the time. Olivia's over here, somewhere in the slip-off slope, in the very thick vegetation. We know we sent her in there to do the berrying reading about an hour ago. We haven't seen her since. But what we can see is we get an idea of how impermeable this area here is, because it's the people standing on it, whereas this is all vegetation, and so it's actually very natural. So a kind of photograph with things highlighted and annotated can be a useful way of presenting data in geography. But it is open to interpretation, because I'm the one who's decided what I'm going to take a photograph of. I'm the one deciding what I want to highlight to you on that photograph. But still useful, very visual. Anybody can look at it and think, yeah, I can see the point you're making. I can see that this is all just like walked over ground. There's no grass here, so the water's going to get in quickly. It might well be eroded quite a lot by people as well as the river.
So what's the bad points of a cumulative bar graph?
A bad point about a cumulative bar graph is that it may only show one part of the cross-section. That's why I put all three alongside each other to make it better. It's not giving you the whole picture. That's why I added an isovel diagram above it. It's not suggesting the reasons for the change, it's just showing you the change. Whereas a scatter graph does give you some potential causes of the change by showing you correlations. That's why in geography we would never use just one single type of graph, but we look at lots of them alongside each other, because they give you a fuller picture of the actual results. Okay? I mean, if you look at your graphs there and you can see the pebble roundness shown, the actual results, can you see a pattern in them? If you look at angular, the number 1 is the most angular type. You see most of that on the left-hand bank there, don't you? Whereas it tends to be less in the very middle, and then it starts to increase again over to the right-hand bank. So what I'm saying to you is, we're seeing a whole lot more velocity and erosion in the middle, and that's causing our bed load to be rounder because of it. So that's a valid conclusion, isn't it? Alright?
Yep.
So you've got isovel diagrams to present, you've got cumulative bar graphs to present bed load shape, you've got a change over width to show the shape as well. Lots of ways of doing it. Can you think of any other ways of presenting data, as well as photographs as well?
Spearman's rank.
Right, Spearman's rank. It's a nice way of checking your data. It's a statistical analysis, a bit like a correlation, in that it gives you the strength of relationship between two variables. And I like it particularly because it tells you either it goes as low as -1 or as high as +1. And anything in the middle, if you were going to draw a correlation, is random. In other words, it doesn't tell you anything. If it's -1, it's a negative correlation. If it's +1, it's a positive correlation.